everyone. In this video, we are going to discuss about electric potential due to a dipole. And let us first discuss electric potential due to a dipole at an axial point. So for this, we will draw a dipole first. So as you can see, there is a minus q charge here and plus q charge here. And the length of the dipole is 2L. So the midpoint of the dipole is O. And we take a point P on the axial line of a dipole. And it is at a distance R from the point O. So now, if this is the charge minus Q and this is plus Q, then we will calculate the potential at point P. For each charge, individually we will calculate the potential here. So, let us write at first. Electric potential at P due to minus Q charge can be written as V1 suppose will be equals to 1 by 4 pi epsilon naught Q by R. Okay, so here we cannot write it R. So minus charge is at a distance of, you can see if it is R and half of it is L and L, so half of it is L, so it will be R plus L. It is at a distance R plus L. We are using the formula for a point charge in each case, which is equal to 1 by 4 pi epsilon naught Q by R. So here you see, and since this charge is minus, so we will write minus here. Next, due to plus Q charge can be written as V2 equals to 1 by 4 pi epsilon naught Q by, now see the distance of Q plus Q from P. Now this is R and this much is L, so this much will be R minus L. If this much is L, half of it is is L, so this will be R minus L. So since potential is a scalar quantity, we are not mentioning any directions. So resultant potential at P will be given by V equals to V1 plus V2. We have to add all the potentials at a particular point. So here we can write 1 by 4 pi epsilon naught it will be, so if you take Q common, so you can be written as minus 1 by R plus L plus 1 by R minus L. So from here we can write it as R square minus L square. Since A plus B into A minus B formula we have to use, then we can get this. So now let us write in this manner. Normal mathematics, we all know this. So after solving, let us write here. So after solving, we can write V as Q by 4 pi epsilon naught. So minus R, then plus L, then plus R, then plus L. So 2L will remain, the R's will get cancelled. Now what we can do, So let us erase some of the portions. Let us write this again here. So 4 pi epsilon naught 2L into R square minus L square. So we have got this. Now as you can see, this Q in the numerator we have Q, then 2 and L. So this can be written as P, 4 pi epsilon naught R square minus L square, because we know dipole moment P equals to 2QL. And so this is your formula. Now if R is much greater than 2L, okay, so if R is much greater than 2L or L, you can write, that means the point P is very far away from the dipole. Then we can write V as 1 by 4 pi epsilon naught P by R square. We can neglect L. If we neglect L, we will get this formula. So this is your formula for electric potential due to a dipole at an axial point. And here you see V is proportional to 1 by R square. In the previous videos we have seen that the electric potential due to a point charge depends on 1 by R, and here it depends on 1 by R square. So you have to remember this. So now we are going to discuss electric potential at an equatorial point. Now we will find out the electric potential due to a dipole at an equatorial point. So as you can see, if you draw a perpendicular bisector of this line, of this dipole, this line, then you will get this line, and on this line we can choose any point. So here we have chosen a point P. At any point you can choose. So we have chosen a point here on this line, and we have joined this with the point A and B. So we have connected point P with A and B. So as you know, the dipole is of dipole length 2L, and this point P is from at a distance R from the midpoint of the dipole. And since it is a right angle triangle, so you can apply Pythagoras theorem and see that this line is of magnitude R square plus L square, root over R square plus L square. If this is L, this is L, this is also L, so this is R, so this is R square plus L square. Now electric potential at P due to minus Q charge can be written as V1 equals to, we are writing 1 by 4 pi epsilon naught as K, Q by distance. So distance is what in this case? So at P you have to find out, so you can write here AP. So root over R square plus L square. Okay. So now due to plus Q charge, what you can write? K into, so here will be 1 minus sign. Now this distance is what? BP, which is equals to K into Q by R square plus L square. So as you can see, the magnitude of, if you leave this sign, so otherwise its magnitude is same in both the case. So as you can see, we have to find out the resultant V here. So resultant potential at P will be given by V equals to V1 plus V2, direct addition we have to do since these are scalar quantities. So V1 is, so let us take K Q common, Just take k by r square plus l square common. So what will be left? Minus q plus q. So it will be 0. So as you can see, the resultant potential at any point on the equatorial line will be 0. So these two proofs are very important for your boards. And that's all for today. Thank you, and stay at home and utilize your time well. Thank you.